So, today we're going to be watching another engineering video. I love engineering, man. And this one is the secret invention that changed World War II. Which I don't know what that is. Probably not the atomic bomb, because last time I checked, it probably didn't look like that. But let's see. I hope it's good.
On September 5th.
Wait. Sorry if you hear any talking in the background. It's my sister. She's streaming on Twitch. So, if you hear that, hey, can't do much about it.
1940, the Luftwaffe began a ferocious campaign targeting London. A sudden change in tactics, focusing the full might of their air force on the most heavily populated city in Great Britain. Over the course of this brutal day, over 1,100 German aircraft entered British airspace.
Useless. I don't know why.
An astonishing invasion to attack a non-strategic civilian target. However, this was all part of the Luftwaffe's plan to gain air superiority in British skies, baiting British fighter planes into the sky to face off against their German counterparts.
Yeah,
a showdown
well that
to
did
eliminate the Royal Air Force as a threat, to pave the way for a German amphibious invasion of Britain. On this first day of the infamous Blitz, over 1,000 aircraft on both sides tangled in the skies above London. The Luftwaffe believed the RAF were on their last legs, but that couldn't have been further from the truth. The Spitfire...
Just a tangent here. The Nazis' intelligence was so bad during the war, man. If you look into that, it's comical. Like, every other person working at in the Germans' intelligence agency was like a double agent. It's hilarious.
and Hurricanes, being manufactured in astonishing numbers, outpacing the attrition of the battle, rose to meet the challenge. The pilots of the Luftwaffe flying the Bf-109 were astonished at the resistance they met. However, another number from this period stands out to me. Over the course of this month, the 6th Anti-Aircraft Division, covering the Thames Estuary, the main approach to London from Europe, expended over 250,000 anti-aircraft rounds in its effort to protect the citizens of London. A bewildering 1,800 rounds were needed to take down a single aircraft on this day, according to official records. These numbers are largely accepted by experts as false, with actual rounds needed much higher. Many downed German aircraft claimed by anti-aircraft crews were in fact shot down by fighters in the sky. The cause of these false reports and anti-aircraft technology's ineffectiveness were the same. So, why was anti-aircraft technology during the Battle of Britain so ineffective at damaging invading planes? And how did an ingenious top-secret technology introduced in the middle of the war change the face of the
animations are
battlefield
really good.
Forever?
I wonder what he uses. Like for the 3D animations, I mean.
At the outbreak of the war, anti-aircraft technology was, for the most part, a deterrent. A weapon that became vastly more effective at lower altitudes, and in turn forced enemy aircraft high above the clouds, where they themselves struggled to hit the mark.
Pre-radar.
The task of accurately targeting a high-flying aircraft from the ground was an even more immense challenge. In the best-case scenario, anti-aircraft crews had a direct line of sight with their target, allowing them to estimate both altitude, bearing, and speed. This information was used to aim their barrels to a location in front of the formation's current location.
And for those wondering how it's done today, you use computers to calculate all of this stuff. And they're way better. People had to do this by but they had range cards and they had to fucking do math. It's crazy.
An educated guess of where they would be when the shells arrived. To make this task even harder, Allied fuses had to be timed on the ground, turning a dial on a mechanically timed fuse. Calculating the time it would take for the round to reach the target in the heat of battle was difficult. These calculations needed to be incredibly accurate, allowing the anti-aircraft rounds to explode.
Either incredibly accurate or just use a really big round that has a big explosion radius.
In close proximity to their target. This variable was also subject to change, as pilots were instructed to change their altitude and bearing randomly to make it impossible to predict flight time and future location. This was a game of chance, and as such, relied on an incredible volume of fire to stand a chance of damaging their target. This problem needed to be solved and was high on the mind of the British as they held through the brutal storm of this bombing campaign. For anti-aircraft rounds to become vastly more effective, they needed a way to detect their target. In the era of fragile vacuum tubes, building an electronic device capable of surviving the immense 20,000 G acceleration launch
Vacuum tubes were made of glass. They were basically light bulbs, so that's why he's talking about it like they're fragile. They are.
out of a gun barrel was a task that was deemed impossible. Work began on radar-triggered fuses in both Britain and Germany before the war broke out, and both abandoned the idea completely for gun-launched projectiles, seeing no way to overcome the technical challenge of ruggedizing the electronics while miniaturizing them to fit into a small artillery shell fuse. However, the Americans persevered and came up with this, the VT fuse, with its ominous red vial of liquid at its core, serving a vital purpose. The challenge of finding a suitable power source for this radar transmitter was another challenge facing the engineers. Early versions of the proximity fuse utilized existing dry cell battery technology, but these came with two huge issues. Their charge would fade in just 2 to 3 months, making long-term storage of these fuses impossible. And secondly, the risk of having power accidentally connect to the transmitter and receiver was far too high. A single failure point could explode an entire ammunition stockpile. For a reminder of what that looks like, this is not a nuclear bomb. This is the SS John Burke, a United States ammunition transport ship that was struck by a Japanese kamikaze bomber while transporting ammunition to the Philippines in 1944.
Yeah, these days this stuff doesn't happen, so people underestimate how explosive normal munitions are, but tell you what, they explode. They sure do.
The war in the Pacific was the driving force for the invention of the proximity fuse. The US were losing an astonishing number of ships to Japanese aerial attacks and desperately needed a better way to defend their ships with anti-aircraft fire. The solution the US National Defense Research Committee came up with to solve this issue of safely powering this device was as bizarre and unique as it was ingenious. The engineer's switch to was as bizarre and unique.
What's this guy wearing? Or is he just like that? Is it maybe the coloring? Because this is obviously a black and white video that was recolored. Bro looks like Data from Star Trek.
It was ingenious. The engineer switched to a wet cell design. This red vial contains the electrolyte of the battery. This allowed for an ingenious workaround for both problems. The liquid electrolyte was stored inside the battery, separated from the solid plates of the battery inside this vial. Underneath this glass ampule lay a breaker that contained a clever mechanism. 2 levers were pushed towards the center of the mechanism by a spring. When the round began to spin at 50,000 revolutions per minute as a result of the rifling in the gun barrel, these levers would be forced out, which released a trigger, allowing a small explosive primer to force a spiked plunger to break free and strike the glass ampule, breaking it and releasing the electrolyte into the battery. The plates of the battery were composed of thin zinc plates coated in carbon on one side, each layer separated by a plastic insulating ring, and each disc had holes punched into it to allow the electrolyte to flow and fill each layer. This glass could, of course, break with rough handling, but the electrolyte would not fill the space between the battery plates without the centrifugal force of the round forcing the liquid outwards into the surrounding plates. Other safety.
How did they make plates so thin back in the day? Because I was under the impression that manufacturing in like the 40s was not good at all. I just wonder, maybe they stamped them, but stamping them won't get them smooth enough. I don't know. Let me know in the comments if you know.
Measures were incorporated to make absolutely sure that the chances of an accidental detonation could only happen when the round was in the air and spun at tremendous speeds. Once energized, this battery would provide power to the oscillator, which generated a continuous sine wave radio current to the transmitter. For space efficiency's sake, the antenna operated as both a transmitter and receiver. With the currents traveling through the same antenna, the fuse needed a way to differentiate between the signal sent and the signal received. For this, the engineers could turn to the Doppler effect. As the target and fuse are traveling towards each other, we can easily calculate the apparent frequency shift due to their relative velocity. Then, with some basic math, we can come up with this equation, subtracting the reflected frequency from the actual frequency. This was called the beat note. This beat note is what the fuse used to detonate the round. The amplitude of this beat signal would also grow as the round approaches the target, providing a signal that looks something like this with amplification. The fuse was tuned to explode at the optimum distance and angle away from the target by tailoring the radar sensitivity to match the fragmentation pattern of the shells. When the round approached the target, the returning radar waves would generate the necessary threshold voltage to trigger the thyrotron, a type of high-speed electrical switch. It looks a lot like a vacuum tube, but it was filled with a low...
Man, people in the 40s were just naming shit whatever, man. Sounds like some science fiction. Thylotron, whatever.
...pressure gas like hydrogen. When a voltage of sufficient magnitude was passed from the amplifier to the cathode grid of the thyrotron, it would ionize the gas inside and allow current to flow to the anode through its glowing cloud of ionized atoms, completing a circuit to a capacitor that in turn would detonate the high explosive charge in the round, creating a cloud of shrapnel at the optimum distance away from the target. This whole assembly, consisting of the vividly red electrolyte capsule, the zinc-carbon battery plates, oscillator, antenna, amplifier, and thyrotron, was then inserted into the fuse body, and the cavities of the fuse were filled with a microcrystalline wax for moisture protection and, critically, mechanically support the electronics to keep everything in place during launch. Packaging this all in a fuse this small in the 1940s was no easy feat. The tubes manufactured for the proximity fuse were drastically smaller than existing conventional tubes. This, of course, helped immensely with resisting the force of launch. With 20,000 Gs of acceleration, every extra gram of weight saving makes the difference. With this multiplication of mass, a single gram would weigh 20 kilograms. The engineering challenge of ensuring every gram of mass inside this fuse was supported by a structure capable of bearing 20 kilograms was immense. A challenge that deterred both the British and Germans, and its success drastically changed the face of the battlefield. The impact this fuse had on
the Germans, no, we shouldn't put all this time and effort into this fuse that'll shoot down 10,000 airplanes, but a tank that's 200 tons, now that deserves our time and effort.
The war cannot be overstated. The atomic bomb was the punctuation mark of this worldwide war, but the statistics back the VT fuse as the most impactful invention of the war. An invention that changed the narrative of the war completely. A counter to the newly invented airplane, causing havoc across every theater of the war. Such importance was put on this invention that it was classified as top secret.
I wonder if we'll have something like this, but for drones, because drones are sort of in the state they were as airplanes were in World War II. So I wonder if there's going to be a new invention coming out for those. Although, I bet the invention to deal with drones is just guns, I'd imagine. I imagine we'll see a return to gun AA instead of missile AA, which is what we have now.
Only approved for use in the Pacific, where any unexploded rounds would be lost to sea. Much of the manufacturing was performed in smaller sub-assemblies to minimize any knowledgeable manufacturer from deducing the purpose of the device, and for good reason. During the London Blitz, it's estimated that 1,800 rounds were needed to take down a single aircraft. But with the introduction of the VT fuse, this number lowered to an average of 85 to 100 rounds, a 10 to 20 times increase in lethality. A jump in lethality that great is akin to the introduction of the machine gun. This was, beyond a doubt, a game-changing invention. At the peak of their production, over 250,000 of these fuses were being manufactured a week. The VT fuse was first fired on January 4th, 1943 on board the cruiser Helena, defending itself from an aerial assault and successfully shooting the aircraft down. This device had a devastating effect on the aerial battles of the Pacific. Japan soon began to run low on trained pilots, and a year later began the kamikaze campaign, sending waves of untrained pilots towards American ships in the hopes just one could get through. In May 1945, 2 destroyers off Okinawa found themselves the targets of 150 kamikaze aircraft. Every single one of them was shot down, a feat that could not have been achieved without the radio proximity fuse, allowing the guns of these boats to fire relentlessly with accurate fire with no pauses to fiddle with the mechanically timed fuses. Had the VT fuse been available during the Battle of Britain, the battle would have been even shorter lived, with the anti-aircraft guns of London suddenly becoming an order of magnitude more effective. The swarms of the Luftwaffe bombers would have stood little chance of returning home. It was finally approved for use over land for the first time in conjunction with the Allied invasion of Normandy, a week before Germany began bombarding Britain with the V1 buzz bomb. At its peak, 100 V1s were launched towards Britain, and with the help of the VT fuse, 80% of these automated missiles were shot down. The VT fuse also played a pivotal role in the Battle of the Bulge, allowing artillery fire to explode at the perfect distance overhead, showering the canopy of the Ardennes forest with deadly shrapnel, repelling Germany's final large-scale counter-offensive of the war. Even at this stage of the war, with Germany on the retreat, the VT fuse was a closely guarded secret. Each and every fuse needed to be tracked and accounted for, with one story of artillery officers spending hours searching through snow to locate lost fuses during the Battle of the Bulge, only for them to be returned to them by locals. World War II was defined by technological progress. When the entire world was at war, a nation's very survival was at stake, innovation was placed at the very pinnacle of national interests. And this is the reason I find the war so fascinating. I have created 2 series, The Logistics of D-Day and Battle of Britain, detailing the innovations that helped win these critical battles. I put little focus on the military tactics or individual.
And it's on Nebula, so if you want to watch them, go there. I'll actually put a link in the description for Nebula. Just, because it feels wrong to use so much of the video and not link to his other platforms. But anyway, yeah, about the VT fuse being top secret. The tank at the time that we were using, called the M4 Sherman, actually had another top secret invention called the stabilizer, which made the gun stable even when it was rolling. And the stabilizer was so top secret that a lot of the teams weren't even told how to use it. So a lot of them didn't use it. And it was a big failure of the time because the stabilizer changes a lot about how you use the tank. If you don't have the stabilizer, then you can't roll around slow with the gun, and you can't peek over corners and peek back. But anyway, yeah. It's just an interesting story. Anyway, I hope you guys like this video. I really like this video, man. Every time I hear about World War II, it always makes me so sad that it fucking happened. And that it's not really talked about as much in America. I mean, we have a lot of schooling about it, but it's not like the real human stories, which is what really impacts people and makes them, understand that war is bad. Anyway, yeah, I hope you like this video. Leave a comment for another thing I should watch in the comment section. And later, yeah, bye-bye. That footage I use is from a YouTuber called Spookston, and I will put them in the description below.